Hello and welcome to yet another thrilling installment of the Pre-Calc videos. This is section 3 and this is called completing the square. And what we want to do is we want to recognize the pattern of a perfect square trinomial as a perfect square of a binomial. We want to use the square root property to solve equations. We want to find complex solutions to quadratic equations by completing the square. Okay, so what we want to do when we complete the square is we want to form a perfect square trinomial, which we'll talk about a lot about that. Write a binomial squared, and then use the square root property to solve. So let's quickly talk about what a perfect square trinomial is, and that's when you have something like this. When you have a quantity, a binomial, meaning you have two terms, something like x plus 3, and you take that entire quantity and you square it, okay? And when you multiply that all out, you end up getting x squared plus 6x plus 9. This is a perfect square trinomial, okay? And what we need to be able to do is recognize this and go to this side. So, if we had something like x minus 4 squared, okay, x squared minus 8x plus 16, 2x plus 5 squared, all that kind of stuff. So if I took this, x plus 0.5 squared, that would give me x squared. Let me come in here and write this. You would get x squared plus an x, and then plus 0.25. Okay, that in fact is a perfect square. Two numbers that add to 1 but multiply to 0.25, and that would be a half. Okay, and then the question over here is going, okay, what number would go here? Okay, if you had x squared minus k times x plus 169, okay, k would have to be 26. Okay, because 13 squared is 169. So if I had, if you wrote it like this, x squared minus 26x plus 169, then that would end up giving us x minus 13 quantity squared, okay? And so just your ability to understand, how to go from this. And remember, guys, the thing about this is that when you have something like x plus 3 squared, it means that you're doing x plus 3 times x plus 3. That means you have two of them. That's why you're squaring it. Okay, and you could always multiply this out and get these trinomials here. Okay, there is a rule of thumb here. You have these, a formula a plus b quantity squared is equal to a squared plus 2ab plus b squared. And then if you had a minus b squared, it'd be a squared minus 2ab plus b squared. Okay, so let's take a look down here and let's write these as perfect squares trinomials. And so what we would have is, if we had x squared minus 10x plus what would make this a perfect square? And that would end up giving us that this would be 25, okay? And I just know because I'm taking this number, what two numbers would add to negative 10 that are the same number, and that would be negative 5. And if I square that number, I'm going to get 25. So this, in factored form, would end up being x minus 5 quantity squared, okay? And so I'm just factoring, but I'm just kind of, thinking about two numbers that add to negative 10, but multiply to 25, okay, to make this a perfect square trinomial, okay? Over here, x squared plus what times x gives us 36. So what two numbers multiplied together that are the same would give us 36, and that would be 6. And then if you did 6 plus 6, that would just give us 12, okay? And this as a perfect square binomial would be x plus 6 quantity squared, okay? And you can multiply that out and try and, get where you need to go, okay? Okay, this one, x squared plus 1/2 x plus what? Now here's what I do to get that number, okay? What I do is I'm going to take this, let me see, okay. What I'm going to do is I'm going to take 1/2. I'm going to multiply that by 1/2, and then I'm going to square it, okay? And so what I end up getting is I get 1/4 quantity squared, okay? And when I take 1/4 and squared, that's 1 squared over 4 squared. That's going to give me 1 over 16. So this number here would be 1 over, 1 over 16. And then this would factor out, and you have to say, okay, what two numbers multiply to or add to a half, but multiply to 1/16, and that would be x plus 1/4 quantity squared. Okay, so in all of these, all right, to kind of figure this out, all right, if I take this middle term here, if I take negative 10 and divide that number by 2, and then square it, that's going to give me negative 5 quantity squared, which gives me 25, okay? So that's how I kind of get this number here, all right? If I take 12, divide that number by 2, and then square it, that's going to give me 6 squared, which is going to give me 36. So again, this number here shows up here. All right, and that's what I did here, okay? And I just kind of know to do that from practicing and writing perfect square trinomials, and we'll go over that. But again, what we do, you know, and here we divided by 2, multiplying by a half is the same thing, okay? So when you have a fraction as your b coefficient here, then you're going to want to take that number, multiply it by a half, and then square it. And then notice how 1/4 is this number that shows up here, okay, when we're writing these things, all right? So again, this is just writing perfect square trinomials. We're not really doing a whole lot. We're just rewriting things, okay? And then once we kind of get to this point here, all right, you know, what I know is that, you know, if I have this equation where it's like x squared is equal to some value, okay, in order to, you know, solve for x, we take the square root of both sides. And what happens is when I apply the square root, we either get a positive square root or we get a negative square root, okay? So if I were to solve this equation, if I had, you know, x squared is equal to 25, you know, if I were to, let me rewrite it real quick, x squared is equal to 25. If I'm solving this, then I'm going to take the square root of both sides, okay? And if I take the square root of x squared, that's just going to give me a value of x. And that's going to end up giving me x equals 5 or x is equal to negative 5. Okay, and the reason why I have to do both is because of this. Because if I take 5 squared, then that's going to give me 25. Okay, but if I take the quantity negative 5 and square it, that's also going to give me a positive 25. So when you solve this equation, you're going to get 2 answers. Okay. All right, let's move on to the next one. And we could do something like this over here. Okay, the same thing applies. If I have, you know, the quantity x plus 3 quantity squared is equal to 25. To solve this, okay, and this is what makes this process so unique and will always kind of work, is that when I take the square root of both sides, okay, when I take the square root of this quantity, then I end up getting that I just get x plus 3, and this is equal to plus or minus 5. Okay, when I take the square root of 25, I get 5. All right, so I get 2 equations here. Okay, I get x plus 3 is equal to 5, or I get x plus 3 is equal to negative 5. So if I subtract 3 from both sides, then I get that x is equal to 2. Okay, here, same thing, if I subtract 3 from both sides, I'm going to get x is equal to negative 8. Okay, and both of those, if I plug those in for x, will satisfy this equation. Okay, but that's the point, is that, you know, guys, this is a quadratic. Okay, equal to some number, and what I can do is solve this using the square roots, and that's why we want to get perfect square binomials, okay, so that we can apply this property and solve these equations, okay? So that's that, all right? So, let's take a look at this, okay? So given this equation, like let's say you've got 2 times x squared is equal to negative 8, and we want to determine what x is. So what I would do first is I would divide both sides by 2, okay? Because then I just get some value x squared is then equal to negative 4, okay? And now what I can do is I can apply the square root to both sides, okay? And this is going to give me x is equal to the square root, and let's write it like this, plus or minus the square root of negative 4, okay? And when I do that, okay, I get this. I get x is equal to plus or minus the square root of 4 times the square root of negative 1. Okay, so when I do the square root of negative 1, that's what's going to give me I. So then I get that x is equal to plus or minus, now remember the square root of 4 is just 2, so this is going to be 2i. Okay, so you can write your answer like this, x equals plus or minus 2i, or you can come in here and say, okay, x is equal to 2i, or x is equal to negative 2i, okay? And either way you write that, you're going to get the same thing, okay? But that's the idea. You want to make sure that you isolate something and you get something squared. Okay, I can't take the square root with that 2 here, because then I'm going to get the square root of 2 and it's just not going to work out the right way. So what I want to do is just isolate that quantity, something that's squared, and then take the square root. Okay? All right, same thing over here. So let's do this. I'm going to write this problem down over here. X minus 3 quantity squared is equal to 49. This will work out nice and neat. But what I want to do, because I have a quantity squared, okay, I can take the square root and get rid of that square. All right, so I'm going to take the square root of both sides. So I end up getting just the quantity x minus 3 is equal to plus or minus 7. Okay, square root of 49 is 7. So then I get this. I get x minus 3 is equal to positive 7, or I get x minus 3 is equal to negative 7. All right, so then I'm going to add 3 to both sides. So I end up getting that x is equal to 10. And then if I add 3 to both sides here, I get that x is equal to negative 4. Okay, so x equals 10, x equals negative 4, and these are the values that we can get for x. We get 2 of them. Okay? All right, let's move on to the next page. All right, so on this one, this shows us the steps of solving this equation for x. And so, we have this original equation. But what we want to do is we want to then we see that this left side is a perfect square trinomial, okay? And so this would factor, when you have this, this equation right here, you can factor this and you go, okay, what 2 numbers add to 12 but multiply to 36? And so you could factor this and say that this is just x plus 6 times x plus 6, okay? But since you have 2 of them, okay, you can write that as just x plus 6 quantity squared, okay? And then what we can do is we can apply the square root property of both sides. We get rid of the squared here, we get plus or minus 5, we set up 2 equations, and we solve for x, just like we did on the last one, okay? So what I want to do is do that for this problem down here. Now this problem is going to be very, very tricky, okay, because you're dealing with a lot of fractions, okay? Now what I know is, and we've already kind of done this one, okay, we want to solve this equation, x squared plus 1/2 x plus 1 over 16 is equal to 4/9. So the way to figure out, how to factor this is ask that question, what 2 numbers add to 1/2 but multiply to 1 over 16. Now the trick is, okay, and here's something that took me a long time to figure out, because I always struggled with these fractional problems, okay? But if I take this middle term 1/2, okay, if I divide that by 2, which is the same thing as multiplying by 1/2, okay, and then I square it, all right, 1/2 times 1/2, I just multiply across. 1 times 1 is just 1. 2 times 2 is 4, and I take that and I square it, all right? And so when I do that, this 1/4 and square it, that's going to be 1 squared over 4 squared, and so that's just going to give me 1/16, okay? So I take this number, I divide it by 2, and then I square it to get this last number. Now the trick is that the number that you divide by 2, after you divide by 2, that's the number that's going to go into your binomial, and you're going to write it like this, x plus 1/4 quantity squared, okay? And that's how you factor that. And that's a hard thing to get used to, but it's the idea of, that's how you get a perfect square trinomial, is that you take this middle term, you divide it by 2, okay? So, 1/4 plus 1/4 is going to give us 1/2, and then you square it to get that last term. All right, and so but then it's that number that you divide by 2, which is what's going to go right here, all right? And this is all equal to 4/9, okay? So let's go ahead and take the square root of both sides, all right, now that we've got a perfect square trinomial on the left side. So now we just get x plus 1/4, and when I do the square root of 4/9, I'm going to do plus or minus, and I'm going to do the square root of 4 divided by the square root of 9. Okay, as a result, I get x plus 1/4 is equal to plus or minus 2/3. Okay, so then what we want to do is we want to write 2 different equations here. Now I've got x plus 1/4 is equal to 2/3. okay? Or I have x plus 1/4 is equal to negative 2/3. All right, so then what I want to do is I'm going to subtract 1/4 from both sides, minus 1/4. So I get this value here that x is equal to negative 1/4 plus 2/3. Okay, let's get a common denominator with that. I'm going to multiply the top and bottom by 3 over 3 here, and this one by 4 over 4. So then I get that x is equal to negative 3/12 plus 8/12. All right, so then I get the value of x is equal to negative 3 plus 8 is 5/12, and that's my value for x, okay? Now, over here on this other one, let's do the same thing. Let's subtract 1/4 from both sides. All right, so then we get that x is equal to negative 1/4 minus 2/3. And same thing over here. I'm going to multiply top and bottom by 3, this one top and bottom by 4 to get a common denominator. And I end up getting x is equal to negative 3/12 minus 8/12. So then I get that x is equal to negative 11/12, okay? And these are my two answers. And guys, the reality is that you have to be able to operate this with fractions, okay? You really need to make sure you're able to do this with fractions. Otherwise, it's just going to be kind of a pain, and you're not going to be able to get through it. So it's important that we do that, okay? Now, over here, okay, I'm going to show you guys the process of completing the square. Remember how we did this thing where you take this middle term and you divide it by 2 and then square it, okay? That's what gives us a perfect square trinomial, okay? So this is really how you solve a quadratic, by completing the square. All the other examples that we've been given, we've already had perfect square trinomials, but now on this part we have to create it. So what I want to do is this, okay? When I have this equation, x squared minus 10x plus 7, okay, the problem is that I don't have a perfect square trinomial here. Okay, I really don't have a method to solve this. So what I have to do is I have to get just my x squared minus 10x term, but I need to move the 7 over. So the first step would be is to subtract 7 from both sides, okay? So I get this. And I get x squared minus 10x plus blank is equal to, and then 18 minus 7 is just going to give me 11. But then if I add something to this left side, I have to do the same thing to the right side. So I'm going to do a plus blank here, okay? Now, like I said, this can't be factored the way that it currently is. So what we have to do is we have to move the constant over, get 11 over here on this side, and then I say, all right, well, I want to turn this part over here into a perfect square trinomial. So I have to think about what's going to go in this blank, all right? And so what I would do, and it says it over here, okay, I would take this part over here, take this middle term, divide it by 2, and then square it, and then add that number to both sides of the equation, okay? So what you end up getting, you know, if you take, say, negative 10, you divide it by 2, and then you square it, okay, that's going to give me negative 5, okay, and then squared, okay, which is going to give me positive 25. So I'm going to add positive 25 to both sides here, okay? Now, what we end up getting here is now a perfect square trinomial, okay, which I can factor. So then you say, okay, well, what two numbers multiply or add to negative 10 but multiply to positive 25? And that answer is this value here of negative 5. So once I, have done this, taken this middle term, divided it by 2, and then, add that number to both sides, what I can now do is I can factor this. And all this does is becomes x minus 5 quantity squared. And I got the negative 5 from right here. Okay, the negative 5 comes from me taking this middle term and dividing it by 2. All right, and that's it. Okay, then over on the left side, I get 11 plus 25, which is 36. So what I can do now that I've turned this into a perfect square and I've factored it, I can now take the square root of both sides and get rid of my square. So as a result, we get x minus 5 is equal to plus or minus 6. Okay, and then I'm going to have two equations. I get x minus 5 is equal to positive 6, or I get x minus 5 is equal to negative 6. Okay, and so what I want to do at this point is then add 5 to both sides. So we get x is equal to 11. Okay, and then here if I add 5 to both sides, then I get that x is equal to, what is that, -1? And that's it. Okay, so it's just one of those, it's a process. Okay, now I'm going to do the same thing down here. Okay, if I have this equation down here, I want to solve x squared minus 8x minus 9 equals 0. Now the question is, what two numbers add to -8 but at the same time multiply to -9? And unfortunately I can't do that. All right, so what I want to do, I can't factor this, so what I want to do is add 9 to both sides. Okay, and as a result I get this. I'm going to get x squared minus 8x plus blank is equal to 9 plus blank. Okay, now let's think about the number that's going to go here in the blank. So I'm going to take my value of -8, okay? I'm going to divide that by 2, and then I'm going to square it, okay? So -8 divided by 2 is going to give me -4, and if I square that, I'm going to get positive 16. So I'm going to add 16 to both sides here. Now, when I manipulate this, okay, on the left side, what I have done is I have turned this into a perfect square trinomial. Okay, so I can rewrite this, and this factors down to x minus 4 quantity squared. Okay, and then 9 plus 16 is just going to give me 25. Now let's think about this. This -4 is the result of me taking my middle term and dividing it by 2. Okay, these numbers will always be the same. All right, so now what I can do, now that I have this perfect square trinomial, I can now take the square root of both sides, and then as a result, I get x minus 4 is equal to plus or minus 5. So then my answer then becomes x minus 4 is equal to 5, or I get x minus 4 is equal to -5. Okay, so then I'm going to add 4 to both sides. So I get that x is equal to 9, or if I add 4 here and here, I get that x is equal to -1. Okay, so I get these as my solutions. Okay, so I know it's kind of a tricky little thing, but guys, this process is there every single time. I always struggled with this, I understood how to get to this step, but then it was going from this step and then factoring it back down was really hard for me. But I just remember that if you take that middle term and you divide it by 2, that's the number that's going to go there, and then that's it. Okay, let's go to the next page. Okay, first thing I want to do here is we want to complete the square to solve the quadratic equation when my leading coefficient is not 1. Okay, so this is a little bit tricky. So I want to go through the steps here. I'd make sure you're writing everything down. What I would do here, first step, is I'm going to divide everything by 3. I want to get a leading coefficient of 1. Okay, everything needs to be divided by 3. So then here, the 3's divide out, so you're just left with x squared. -30 divided by 3 gives me minus 10x, and then 87 divided by 3 is equal to 29. So this is going to be plus 29, and then this is equal to 0. Okay, so now what I have is I have this trinomial, and I'd love to factor this by, or I'd love to solve it by factoring, okay, but I can't do that. What two numbers add to -10 but multiply to 29? 29 is a prime number. It's only divisible by itself in 1. So I can't really do anything here. Okay, so what I need to do is I need to solve this by completing the square. Completing the square will always give you an answer. So I'm going to subtract 29 from both sides, okay? And so then I get x squared minus 10x plus blank is equal to -29 plus blank. All right, so now what I need to do is get a perfect square trinomial on this side. So I'm going to take my middle term, which is -10. I'm going to divide it by 2, and then I'm going to square it. Okay, and that's going to give me -5 quantity squared, which is going to give me positive 25. So I'm going to put plus 25 here and plus 25 here. So now, if I have x squared minus 10x plus 25, this is a perfect square trinomial, okay? And I can factor this down to x minus 5 quantity squared, and that's equal to negative 4. Okay, so remember, the negative 5, okay, this value here comes from me dividing that middle term by 2. Okay, and that's going to be the case every single time. All right, so now what I want to do is I'm going to take the square root of both sides. All right, and so I'm going to get x minus 5 is equal to, and this is going to give me plus or minus 2i. Okay, the square root of negative 4, remember, I can rewrite that as the square root of 4 times the square root of negative 1. Square root of 4 is 2, square root of negative 1 is I. Okay, so then what I want to do is I'm going to add 5 to both sides. And so we get that x is equal to 5 plus 2i, or x is equal to 5 minus 2i. And so here we don't get real solutions, we get complex solutions, and that's okay, okay? But remember, guys, my process of doing this isn't any different. The only thing that was different was that we have to make sure our leading coefficient is 1. So when we have a value here, we just divide everything by that number, and then we just continue on as usual, all right? All right, let's take a look at this next one. And this next one's going to be kind of tricky, all right? So what I want to do is I'm going to divide everything by 2, all right? What I've noticed is that we've got a leading coefficient of 2, so I'm going to divide everything by 2, by 2, by 2, and by 2. So as a result, I get x squared, okay, plus 1/2 x, and then minus 2 is equal to 0. So the question is do I have any numbers two numbers that add to 1/2 but multiply to negative 2? Okay, you can sit here as long as you want trying to do that, but it ain't going to work. So what I want to do is this. Okay, I'm gonna add my 2 to both sides, and so my next step in my equation is going to be x squared plus 1/2 x plus blank is equal to 2 plus blank. Okay, so the question is what's going to go in this blank? All right, so remember, what I want to do is I'm going to take 1/2, my middle term. Okay, I could divide this by 2, but let's just multiply by 1/2. That means the same thing. I'm going to get that, and then I'm going to square it. So this becomes 1/4 quantity squared, all right? And 1/4 squared is 1 squared over 4 squared, which is going to give me 1 over 16. So 1 over 16 is going to go here, and then it's also going to go here, all right? So now, all right, let's do some math over here on the right side. 2 plus 1/16. Let's do that up here. If I've got 2 over 1 plus 1 over 16, I'm going to multiply this top and bottom by 16 over 16, and this is going to give me 32/16, okay, plus 1/16, which is going to give me 33/16, okay? So let's rewrite that over here. I'm going to write this down. I'm going to say x squared plus 1/2 x plus 1/16. 1/16 is equal to 33/16. Okay, so what I can do, okay, x squared plus 1/2 x plus 1 over 16, this is now a perfect square. Okay, now to factor that, we have to remember what's over here, this 1/4. Okay, and so what I want to do is I'm going to do x plus 1/4 squared. Okay, because 1/4, because I'm creating this 1/16, okay, to get a perfect square. I'm taking this middle term, I'm dividing it by 2, and then I'm going to square it. So this is the number that if I add, 1/4 and a 1/4 added together are going to give me 1/2. But if I multiply it by itself, it's going to give me 1/16, okay? And so that number is always going to be here, all right? And that's the trick about doing this, is about factoring that, understanding how that's going to work. Okay, and then this is all equal to 33 over 16. Now what I can do is I can take the square root of both sides, all right? And so on the left side, I get x plus 1/4 is equal to, and what should I do over here? I'm going to do plus or minus the square root of 33, okay, divided by the square root of 16. Now, what I have is I get x plus 1/4 is equal to plus or minus the square root of 33 all over 4. Okay, square root of 16 is 4. All right, so now if I subtract 1/4 from both sides, all right, then I'm going to get the answer of x equals negative 1/4 plus or minus the square root of 33 over 4. Okay, you can leave your answer like this. Okay, that is acceptable. Okay, if you wanted to finish it out though, you would want to do, okay, let's do x is equal to negative 1/4 plus the square root of 33 over 4. Okay, or you would do x equals negative 1/4 minus the square root of 33 over 4. All right. So as a result, you're going to, and you have a common denominator here, but you can't combine your numerators. So you could do negative 1 plus the square root of 33 all over 4. Okay, and down here you could do negative 1 minus the square root of 33 all over 4. Okay, so either way, any of these answers would work, but you got to make sure that you can distinguish in between in between them. All right. That's a good problem. That's a fun one. I like that one. Okay, so that concludes this video. I know it's a long video. I know it's a lot of stuff, but please make sure you're starting the homework and getting started on the assignment and the quiz. Okay, see ya. Bye.